Okay, hello, AP Pre-Calculus. I hope everyone is having a good day. I apologize for not being in class today. But today we're going to talk about piecewise defined functions. Okay, now this is not a topic that is necessarily taught, or there's no curriculum for it in AP Pre-Calculus. It's just kind of thrown in there. And you guys have already kind of seen a few piecewise functions. This is an example of a piecewise function in your homeworks and in our activities. I just wanted to have a lesson that kind of defines what the heck this thing is and how we use it and how we can get information from it. Because I feel like there was a little bit of confusion with it because we haven't really talked about it too much. Okay, so when a function is defined by different equations on different parts of its domain, it's called a piecewise defined function. And the reason why it's called a piecewise defined function is it can be made up of two or more pieces of two different graphs. Okay, so how we, first off, let's try and find some values. Okay, now when I say f of -2, I am saying x is -2. With a piecewise defined function, I have to figure out where that is in my two options. Okay, so -2 is less than 0, so I'm going to use the top equation. So f of -2 will be 2 times -2 plus 3. So that's -4 plus 3. So f of -2 is equal to -1. Okay, and you do the same process for the other two, but I want you to notice, okay, for a piecewise defined function, only one of them will get the little line underneath if it's the same number. Okay, so in this case, because f of 0, okay, because this second one has the equal to little line, that means we'll plug 0 into this bottom equation, not the top equation. Even though we see a 0 here, we don't see a little line underneath, so that means we cannot equal 0, okay? Here we can. So when we find f of 0, we plug into that bottom equation, which is just 3, okay? And then 2, because x is greater than or equal to 0, we'll plug 2 into that bottom one as well. Now, how we graph it, okay? We graph linear equations. These are both linear equations, which is really nice. We graph them normally, okay? But because it specifies that this one is less than 0, okay? At 0, we will have an open hole. At 0 here, we will have a closed because we have that line, okay? So that's something you're gonna gotta wash out with piecewise functions. So 2x plus 3, we have a y-intercept at 3, but at that y-intercept, we have an open circle because cannot equal 0. And the y-axis is where x is equal to 0. Now, because we have a slope of +2, okay, but we are only to the left of 0, I'm just going to graph backwards. So that means I'm going to have a line that looks kind of like that. Okay, so that is my first piece. Okay, I'm going to kind of color code. There's our first piece. Here's our first piece. Okay, so now our second piece will be, I'm going to use blue, will be this guy. Okay, if you notice, they have the same y-intercept. Okay, so because they have the same y-intercept, we can equal 3. Okay, but again, I want you to know that that first piece has an open circle at 3. Okay, and then we have a slope of -1/2. So that one will work normally. We're not going to work backwards in that case because we are going to the right and down. So that'll look something like that. Okay, so this is a piecewise defined function. It's made up of two different pieces, two different graphs made of two different equations. Okay. Mhm. You would do a very similar process for example 2. Okay, find where this is in your inequalities. Okay, this is x is less than 0, x is greater than or equal to 0. Wherever those variables or wherever those values land, that's the piece you plug into. Okay. The thing I wanted to focus on here, though, okay, is finding x and y intercepts, okay? Because this is what's kind of asked about on the AP test a lot, okay? So finding x and y intercepts of piecewise functions is a little difficult sometimes, okay? The reason why, okay, we have to make sure that the pieces we're finding, the values that we get actually match their inequalities, okay? So first off, an x-intercept is when y is equal to 0. The y-intercept is when x is equal to 0. Okay, y-intercepts are much easier to find. X-intercepts are a little more difficult, in my opinion, but that's just me. Okay, here we have it pretty easy because our functions are linear. Okay, so I'm going to start with our x-intercepts. Now, what I want you to know, okay, x-intercept is when y is equal to 0. So we have x plus 4 is equal to 0. I'm going to find this for all pieces, okay, and I'm going to figure out whatever values I get. If they work in our inequalities that were given for those pieces, that's an x-intercept. We could have more than one, okay? So in this case, x is equal to -4, okay? But I want you to notice for that top piece, -4 is not included in this domain. We stop at -2, okay? So this piece, this is not included in our domain. So this is not an x-intercept, okay, of our piecewise defined function because it's not included here, okay? Second piece is just a number. So we will not have an x-intercept. This has no x-intercept. Because if I did, that would mean, don't write this down, it is equal to 0. And we know for a fact that's not true. If that was true, we'd have to make some different light choices, okay? But it doesn't equal 0, so we definitely don't have a y-intercept on that second piece. So now we'll see if we have a x-intercept in this third piece, excuse me. So we have -x plus 3 is equal to 0. Okay, so then we have -x equals -3, so x is equal to 3. Now, is that included in the domain of this piece? Yes. Okay, so because this is included, x is greater than 3, and this is greater than 1, I'm sorry. 3 is greater than 1, okay? This is an x-intercept, okay? So this is included in our domain. So this is an x-intercept. Okay, so the tricky thing about x-intercepts with a piecewise defined function, again, whatever value you find, make sure it works in the inequality that you're given for that piece. Okay, so that's the tricky thing about x-intercepts. Y-intercepts are pretty easy. You find where x is 0. Okay, so for a y-intercept, x equals 0 on this inequality. So our y-intercept will be on that piece. Okay, so 0 plus 4 equals 4. So our y-intercept is at 0 comma 4. Okay, so y-intercept, we only have to find one thing. Okay, we don't have to plug it into all three of the pieces or all of the pieces that we have, because we could have more than 3 or less than 3. Okay, y-intercept, just figure out which inequality includes the 0, and that's where your y-intercept is going to occur. Okay, so that's how x and y-intercepts are found with a piecewise function. Again, x-intercepts, set your piece equal to 0, solve for x. Okay, figure out if that x works in the inequality for that piece. In this case, because -4 is not in this inequality, we stopped at -2, okay? We did not have an x-intercept on this piece. This one, it's just a number, which means we don't have an x-intercept. But this one, when we solved it, we got a value of 3. And we know for a fact that 3 is greater than 1, okay? So because that inequality remained true with our x value that we got, okay, we do have an x-intercept on that piece. Okay, so go ahead and work through that next one for me, please, and we'll continue on. Okay, now graphing a piecewise function. We already kind of started with that, okay, but I wanted to do a little bit of more of a difficult one. So x squared plus 2, okay, that's a quadratic, okay? We know that it has a y-intercept at 2, because that's just how that works. Okay, but I want you to notice that our inequality starts at 1, okay? So even though that doesn't have the line, I'm going to try and find where our open hole will be, okay? So what I'm going to do, I'm going to plug my starting and end points of my inequality. Okay, that will help me accurately graph where each piece occurs. I just have to remember which one has the open and the closed circles. Okay, so when I plug in 1 to that top equation, okay, I get 1 squared plus 2, so then I get 3. So my open circle in this case will happen at 1 comma 3. So there's my open circle of my first piece. Okay, and this is a quadratic, so it's going to look something like that. Okay, if it's not perfect, it's not perfect. Okay, so that's my first piece. Okay, this is so at 1 comma 3 is the start of the first piece. Okay, now do the same thing for that other piece. So I'm going to have 3 times 1 minus 5, which will give me -2. So my start of my second piece will be at 1, -2. And this one will be a closed circle because I see that equal to sign. Okay, finding our endpoint, plugging in 3. We have 3 times 3 minus 5. That gives me 4. Okay, so at 3 comma 4 is where my ending point will be. And again, this will also be a closed circle because I have a equal to sign. So my piecewise function will look like that. Okay, and again, this is where they get the name piecewise function. This is two different pieces, but it's still a function because we passed the vertical line test. Okay, so that's how piecewise functions work. Okay, I just wanted to talk about this last one. Okay, this last one is going backwards. We are going from a graph to an equation. Now, how we write it, it didn't specify a name here, so I'm just gonna assume f of x. I'm gonna draw a very large curly brace. Okay, I have two pieces here. Okay, I have this guy. I'm gonna start from left to right. I'm gonna start with this guy. Okay, I notice as I move left to right on this guy, I have a negative slope. Okay, so I have a negative slope. And this slope is a slope of -1 because I have a point at -1, 1. So my change in y over change in x here is -1. So I have negative x. I have a y-intercept at 0, so that's just negative x. Okay. But if I notice here at the end of this graph, I have an arrow. So that means I'm going off to negative infinity on that left side, and then I stopped at 0. So my inequality here will be x is less than or equal to 0. And the reason why it's equal to, I have a closed circle right here. Okay, so that's my first piece. Second piece, I still have that negative slope of 1, okay, but I have a y-intercept at 2. So negative x plus 2. But I have a starting and stopping point here. I started at 0, so I have 0 is less than x. I don't include the line underneath because I don't have a closed circle. Okay, and then I go to 2 and I stop. And that one I do have a line because I have a closed circle. Okay, so that is how we write a piecewise function. Figure out what kind of graph your piece is and figure out what inequality it follows. Okay, so I hope that helped a little bit. I know piecewise functions were just kind of thrown in, and they were kind of touched on in algebra 2, but not to the extent that I kind of wanted. I wanted to make sure that y'all kind of got a better foundation on what a piecewise function is, specifically on finding these x and y intercepts, because that is a little tricky with especially that x-intercept. So I hope this helped a little bit. I know it was a short video, but please like and subscribe to my YouTube channel. I will see you all on Monday.